So we start our science topics talking about minerals. And minerals, this is also a good example of why you shouldn't always just copy down the textbook definition. Because of course the textbook definition of a mineral is a naturally occurring solid with a naturally occurring inorganic solid with a repeating crystalline structure and a definite chemical composition. You write that down. But what exactly does that mean? So what we're going to go through, and you read this yesterday, but let's go through briefly a little bit about what each one of these things means in your own words so that it makes sense. Because it's harder to remember things if you're just memorizing big crazy words that don't make any sense. So naturally occurring, that's pretty easy. Naturally occurring would mean it occurs naturally. It's found in nature. It's found in the earth. Basically that it is not man-made. So we could say found, since we're talking about minerals, found in Earth's crust, and most importantly, not man-made. And so you just watched the brain pop about crystals. A diamond is a type of a mineral. Can we make diamonds?
Yeah.
Yes. So man-made diamonds, are those technically a mineral?
No.
No. So just kind of a little fuzzy gray area, but if it's something that humans have made, it's not technically a mineral. All right. Inorganic. Inorganic. In as a prefix means not organic. So not organic. What does that mean? It's kind of a tricky one. Yes. Yes, it's not alive and it's never been alive and it's not made out of things that used to be alive. Right? So inorganic means not alive. And so this is interesting. Inorganic, it's not. So the one example they give in the textbook was what? What's something that we mine that's actually not a mineral? Because it's organic.
Coal.
Coal. So for example, coal, because coal is made out of what? Coal is made out of basically dead living things that have decayed and been compressed into this material that we can burn for energy, much like burning wood. So coal is not a mineral because it used to be alive. It's from decayed living things. The other similar example that we sometimes think of, and so in this case, coal could be considered a rock, but it's not a mineral. The other thing is if you have rocks with fossils in them, the fossils are not minerals. And the other big example is dead corals and shells. Coral itself is alive, but like dead coral reefs, those have like calcium carbonate and stuff like that in them, but those are technically not minerals because they used to be alive. Anyways, inorganic. Solid, that's pretty obvious, right? And again, as I mentioned before, water is not a mineral because it is not solid at basically room temperature. So solid at, we'll just call it room temperature for now. Scientists call it standard temperature and pressure. Probably won't hear that again until high school chemistry. But so it's a solid when you find it. Does anyone know there's actually most of the elements on the periodic table of elements or many of the metals that we mine, metals that we use, are considered minerals. Which metal is actually a liquid?
Metal's a liquid? So
Yes.
liquid?
What is it? Mercury. So mercury is actually a metal that's a liquid at room temperature. They used to use it in thermometers, the silver stuff in thermometers, but it's a heavy metal that it's obviously really bad if you ingest it, eat it. So they don't use it in thermometers anymore. So now all thermometers usually have red stuff in them, which is alcohol that's dyed red. Anyway, and then crystal structure.
So,
Yes,
solid or liquid? You said most metals are liquid.
the only metal that's the liquid is the mercury.
Oh,
But the other elements, some of the other elements exist as a gas. So those wouldn't be, um, so oxygen, neon, all those ones that exist as gases, nitrogen, those ones are not minerals. Okay, so crystal structure, and we saw this yesterday when we looked at our samples. Obvious examples that we're familiar with would be things like a quartz crystal or, yeah, diamond crystals. There's a really pretty one that I'll find the rest of my samples. It's called galena. It's ore of lead, but it's in its natural form, it has these cubic crystals. How many people have ever, this is kind of weird, how many people have ever looked at salt, like table salt, under the microscope? Or even if you look at it really close. What's it look like? Yeah, little cubes. And actually, tomorrow my seventh graders are going to get the microscopes out to look at their ponds, but maybe we'll put some salt out there so you can see. But minerals have a repeating crystal structure. And so that crystal structure that you see in salt, like table salt, which is sodium chloride, is one of the characteristics of crystals. And then finally, and this is another one that we saw yesterday, a definite chemical composition. Minerals, a certain mineral always has the same chemical makeup. So salt, table salt, is always sodium chloride. Gold, as a mineral, is always just pure gold. And then you've got silver. Let's think of a mineral that's not gypsum. I'm not sure, but gypsum has a certain one. There's silicone crystals. There's like calcium chloride, calcium carbonate. So you've got a bunch of things, but always it's the same throughout. And what that meant yesterday, as we looked at, is this a mineral or is this a rock? It always looks the same throughout. So if you're looking at a sample, like the granite we looked at yesterday, you could see pink and black and gray and white. If it has a bunch of different things making it up, it's not a mineral, most likely. It's a rock made of different minerals. So that is our naturally occurring inorganic solid with a crystalline structure and a definite chemical composition. And furthermore, we're not getting into a lot of detail on this, but different crystals have different minerals have different crystal structures. Calcite has a very distinctive um, crystal, which is different than the quartz crystal. And that's what Tim and Moby were talking about, identifying different things that look the same on the surface. When I give you your assignment where you're going to actually do a little investigation on a particular mineral that's mined in Colorado, you might talk about some of these things, how we know it's a mineral and some of these qualities. All right, everybody caught up there? Yes? Okay, how and where minerals form. And these pictures are straight from the textbook. We talked a little bit about this in our Do It Now. The ways minerals form, evaporation is one way they form. And so you have water, and this happens in any large body of water. The Great Salt Lake is a big example of that many of us are familiar with. And so here, and it's a little hard to read, it says minerals formed by evaporation. So as the water evaporates, you get the crusty white stuff. And it's not just salts, calciums, other things like that. This is gypsum that we talked about a little bit yesterday. Gypsum is used in sheet rock, wallboard, things like that. It's formed by evaporation, and you find it in caves sometimes. Uh, Gypsum rose, it's a little bit weird, but one of the ways it forms is like that. And so this just says water containing dissolved minerals. So ponds, lakes, oceans, any water like that. And again, this is how the mineral deposits formed. As you guys pointed out, the minerals are already in the water, and that just forms that. Minerals form, so that's minerals forming on the surface. They also form in the crust. They form in volcanic areas. You can have a hot water solution that cools, so the water is heated up because of like hot springs. You guys have been to hot springs, right? How do they smell? Sulfury, kind of stinky. There's a lot of minerals in those solutions. And because of those hot water solutions, this is the third way I couldn't think of earlier, hot water solutions are going to produce different minerals than, than just the evaporating on the surface. So minerals formed in hot water solutions, and again, we have those in Colorado. And then cooling magma. Cooling magma is when, again, so you've got rock that is melted, and as it melts, things with different melting points might settle out. So this says tourmaline crystals form as magma cools deep beneath the surface. This says pure silver can crystallize in veins from hot water solutions. And so we have those two. And again, these are pictures straight from the textbook, but that's how minerals form. And that's why we have veins of mineral underground, and we have minerals on the surface. So those are the two main places we find it, the three main ways they form. And again, as you look at your mineral project that you're going to do the end of this week and beginning of next week, you can look at, you know, if it's being mined in Colorado, how did it get there? Is it near hot springs? Is it an area that maybe had volcanic activity in the past? All right, everybody caught up with this? And this is section 2 in the textbook, so you probably didn't read that yet yesterday. Okay, how do we identify minerals? This was in what you read yesterday, right? Yes. Right. So you've got that repeated evaporation, so you've got mineral buildup. And actually around here too, depending on where you live, there's a different mineral content in the water just from the water going through the rocks and that. And so we get mineral buildup, you know, in your pipes or in your sink or on your bathroom wall, you know, the shower walls. That's mineral buildup, and they call it hard water. Hard water just means it has a lot of minerals in it. But that's exactly what happens. Or like a pan that you continually boil water in, you'll get that buildup. It's exactly what it is.
You get the mineral buildup in a stomach.
Well, no, because your body either absorbs it or processes it or gets rid of it. Well, okay, so let me back up on that. He said, can you get mineral buildup in your body? Now, the other thing about that is heavy metals like lead, mercury. These are things that your body can't process. And if you have it in your diet, which is usually from some sort of pollution, it can cause actually things like birth defects or lead poisoning actually causes symptoms that are kind of like mental retardation. They make people kind of slower mentally and harder processing. And some of that, if you had, they used to make pipes out of lead because lead doesn't rust like iron pipes rust. And so that was a problem because then if that lead, or you had lead-based paint, because lead in the paint allowed you to have brighter colors, brighter reds and that sort of thing that didn't fade. But then if little kids, you know, chew on things, and so that type of mineral buildup, yeah, it does build up in your tissues. And mercury poisoning can cause a lot of things. Mercury is found, sometimes it'll be in fish because of pollutants in the water. It's actually a big deal with pollution. Um, some chemicals, pesticides and stuff that we use to kill mosquitoes, they get, anyways, all the way up the food chain, and then the top level predators had things like bald eagles had their shells didn't form properly because of buildup of toxins. So there you go. Yes, it does build up in your body, slightly differently than you're thinking. Yes. Oh, very good. Okay, kidney stones. And kidney stones are apparently ridiculously painful. I fortunately have never had one. Kidney stones, does anyone know what they're made of? Calcium. So calcium, which yes, it's a mineral, if you have too much of it, and some people, like so many things, some people seem to be more prone to it. But for some reason, it comes out of solution in your urine, and it gets to be too much of it, and then it gets stuck in the little bitty. You guys remember? Uh-oh, seventh grade review. Here's your kidney. Oops, that's kind of a silly shaped kidney. It does. And then here's the ureter. So you have two kidneys. And then these do the filtering, and then the urine forms and then goes down there to your bladder, right? But what happens is all these little tubes, and that little calcium crystal gets stuck in those little tubes. And calcium crystals are crystals, they're kind of pointy, and is apparently incredibly painful. And then there's basically two or three ways to treat them. One is just to wait for them to pass, which means they have to go through everything and out, which is also apparently quite painful. Yeah. And or they can use ultrasound to like vibrate them, break them up into little pieces. Those are the two main ways. There might be a chemical way to dissolve them too. So yes, more mineral buildup in the body. Yes. Yes, very good. So if you're not drinking a lot of water, again, back to last year when we talked about this, if you're well hydrated, your urine is more dilute, doesn't have as much of all the nasty stuff in it because you've just diluted it. So if you're not drinking a lot of water, the urine's more concentrated with waste and other chemicals, and that would absolutely be one thing. And that's when you're trying to get rid of them, drinking lots of water. All righty, let's go back to identifying minerals. Yes? Excellent. So when we identify a mineral, and again, in the past I've done a lab doing this, but we're going to skip through this and just talk about it a little bit. How do you know the difference between a diamond and quartz? How do you know the difference between gold and fool's gold? Well, each mineral has a unique color, streak, luster, density, hardness, crystal system, and cleavage and fracture. So let's take a quick look at all these things. Color. Well, that's obvious, right? We all know that gold has has a gold color. Strangely, fool's gold, which apparently fools a lot of people, or did in the past, has a much more greenish color. So iron pyrite, or fool's gold, has a little bit greener color. And then this is another one that's kind of, again, these pictures are from the book. In the textbook, you probably see them a little bit better. But obvious things, diamond and quartz crystals are both clear and colorless. Colorless, that is their color. They don't have any. So then streak, or the streak test. Now, the definition of this in the book is the color of the mineral when it's powdered, which kind of to me doesn't really make sense. But what it means is when you scratch it on a white piece of tile, on a white piece of ceramic, not like the shiny side, but the rough side, it leaves a certain color. And so like there's this one called malachite, which is usually it's a mineral that's bluish or greenish, but it makes a green streak. Hematite, which is an iron-based one, leaves a reddish stripe. Most of them, it's very predictable, but some of them, it's very strange, and it doesn't leave a streak at all. So it's the color of the mark when you scratch it on a ceramic tile. And again, we'll have stuff out so you can kind of play with this and take a look at it, but not actually do the lab. So color and streak. Then luster. And you might remember the Tim and Moby, the brain pop yesterday on minerals, goes over all of these things. So it's a nice little way to review. Luster means how shiny it is. But it's not just shiny or not shiny. It's a little crazy. But there's metallic. You guys all know what metallic luster is, right? Looks metallic. It looks like silver or gold. It could be glassy. Pretty easy, right? Quartz crystal has a glassy luster. Waxy or pearly. Waxy, greasy, or pearly. That's a little weird, but you can imagine what that looks like, right? It's got a pearly kind of color, or so it's kind of opaque, kind of solid looking. Submetallic or dull, and that would be like the graphite in your pencil. It's not quite metallic, but a little bit. Silky. Now, to me, the difference between silky and pearly is, I'm not quite sure what that is. And then earthy. I don't know, looks like dirt. But the obvious ones, metallic, glassy, pearly. Those might be one way that you identify one thing and another. Then density is a big one too. So density, of course, is how tightly the minerals are packed. Everybody knows if I had a ping pong ball and a golf ball, which one's more dense? The golf ball, right? Because things are more tightly packed in it. When you looked at the gypsum yesterday, the gypsum's fairly soft and not very dense. Um, many of the other ones are denser. And so that's mass divided by volume. No big deal. Good? Okay. And then hardness. This one, and it's funny because they use something called the Mohs hardness scale. But what you need to remember from this is just kind of some of the basics. So look at this. Quartz crystal is a 7 on the hardness scale. Quartz crystal is really quite hard. Diamond is a 10. It is the hardest known mineral, and it can scratch any other surface. So here's the easiest way to tell if it's a diamond or a quartz crystal. Scratch it against quartz crystal. If it's a diamond, it will actually scratch the quartz crystal. And then other ones, feldspar is one of the ones that's in different types of granite. So granite makes a really nice hard surface for your kitchen countertop. Oh, look at this, feldspar. Can't be scratched by a steel knife. So I guess you could just take your knives and cut right on your granite countertops. Don't tell your parents I told you to do that. I wouldn't do that. Right? And then calcite, a fingernail cannot scratch it, but a copper penny can. So this is how you just basic things like this. But then you get way down here to the softest ones. Gypsum, a fingernail can easily break down gypsum. And then you have talc, softest known mineral, and that's like talc, like talcum powder, baby powder, very soft. You just crumbles apart. Okay? So again, the Mohs hardness scale, you just know that how easily it scratches another thing. Diamond is the hardest. Gypsum and talc are the softest. Pretty straightforward. Yes.
So, I remember I hear a lot of, like, you've probably heard cut a diamond.
Yes.
So, but I'm pretty sure they use, like, some blades with some diamond on them. But it would be but they wouldn't be able to scratch it. I would hear that they would slowly do it over time. So I'd imagine for, like, the one that has 6 on the scale.
Yes.
You could scratch it with a steel knife if you just did it quite a few times.
So for the hardness, in the pure sense, you can't scratch it. You can break it, right? So if you took a quartz crystal and smashed it with a hammer, it would break into smaller pieces. And when they cut diamonds, right? You're saying cutting the diamonds, but I believe what they do is cut. You've seen like when they make flint blades out of things. You're not cutting it, but you're hitting it just right so it breaks in a particular way, right? Um, and then you've heard like diamond reinforced blades. The diamond blades, diamond tipped blades, there is a bit of diamond dust or diamond uncut diamonds because it's hard. Crystal structure we talked about briefly. I won't go into this a lot, but you can look at it and see the different, so a hexagonal prism or the crystal structure helps identify it. Fracture and cleavage. So this is kind of what you're talking about. How many people know what mica is? So mica, a lot of people get confused and they think that it's a very soft mineral. It's not soft, but it flakes. Mica is so easy to identify because you find it and with a pocket knife or with your fingers, you can just peel it into these paper thin, clear layers. And what we always call black mica is actually a slightly different one. It's called muscovite, but mica. And then fracture means it doesn't have straight edges. So mica, or excuse me, quartz, even though the quartz crystals have straight edges, if you hit quartz with a hammer and broke it, you get these rounder edges. Things like obsidian, things like, like stone tools have that kind of, so flint, obsidian, chert have that sharp, and then make a nice sharp edge. So fracture and cleavage is very distinctive of different minerals. Okay, and then finally there's the last few special properties. Some minerals are fluorescent. You put a black light on them, they glow. It's very cool. Some are magnetic, like this one called magnetite, which is a very helpful thing. Calcite does this weird bending the light thing. And some things are radioactive. Oh, or reactive. I'm sorry. Reactive also like they react, they fizz, they reacts to acids.
That's
Okay, and I think, let me quickly check. All right. So those are all the things. The reason I give you this, and you can rewatch this flipped lesson, is when you start your mineral project, one of the things you're going to need to talk about are some of its chemical properties. How do you know you found gold? How do you know you found silver? And what are some of the properties that make it hard or easy to mine? Any questions? And that is all in the textbook, sections 2 and 3, chapter 3, sections 2 and 3.